This video is about how opioids function, focusing on the opioid fentanyl. Fentanyl was first synthesized in 1959 as an opioid pain medication by Paul Janssen. It was then introduced into medical practice as an intravenous anesthetic in 1960, and then was developed into a safer transdermal patch in the mid-1990s. During this time, fentanyl became a recreational drug, and overdoses caused by the drug started appearing in the late 1970s. The reason it causes overdoses is because of its high potency. It's approximately 50 to 100 times more potent than morphine, and its analogs are up to 100,000 times more potent. Fentanyl has had a heavy impact on society close to home here in Canada and Alberta. According to Global News Calgary, it has been confirmed that there have been 176 overdose cases so far this year, between the 1st of January and the 13th of May. And it is projected that that number of fentanyl-related deaths is likely to increase. This shows that fentanyl is definitely in the social conscious and should be understood why it is so addictive and dangerous.
So to understand how fentanyl works, it's important to first understand how opioids in general work. So opioids are a general group of analgesics which are commonly used in clinical practice as anesthetics. Morphine is the poster child of opioid analgesics, which is why it is a useful opioid to compare fentanyl to. Opioids can be classified according to their effect at opioid receptors. So they can either be agonists, partial agonists, or antagonists. So agonists will bind to the receptor and produce a maximal response from the receptor. Antagonists will bind to the receptor but produce no functional response, and at the same time they'll prevent an agonist from binding to the receptor. And then partial agonists will bind to the receptor but produce a partial functional response. Fentanyl is categorized as an agonist. Opioids are also categorized according to the type of opioid receptor at which they produce their effects. And so there are three types of opioid receptors, which are all G-protein coupled receptors. They are the mu, delta, and kappa receptors. Fentanyl has a larger affinity for the mu receptor, and these receptors are distributed throughout the central nervous system and to a lesser extent throughout the rest of the body. Agonists binding to the mu receptors may cause analgesia, sedation, respiratory depression, nausea, vomiting, and reduction in gastric motility. So the agonist binds to a G-protein coupled opioid receptor, which causes the alpha portion of the G-protein to exchange its guanosine diphosphate, or GDP molecule, with the available guanosine triphosphate, or GTP. This allows the alpha GTP complex and the beta gamma complex to dissociate away and interact with target proteins. This then results in the inhibition of adenyl cyclase, which reduces the amount of cellular cyclic adenosine monophosphate, or CAMP, which is involved in pain modulation as a messenger molecule. The complexes also activate potassium conductance and inhibit calcium conductance. All these changes to the neural cells results in reduced neurotransmitter release. The mu receptors in the midbrain is thought to be the major area for opioid-induced analgesia. This helps to reinforce why fentanyl is such a potent opioid, since it has a very high affinity for these receptors.
Why is it so potent compared to other opioids such as morphine? This is because fentanyl has a very high binding affinity for these mu receptors than any other opioids such as morphine. High binding affinity correlates to a high analgesic potency. Opioids binding to mu receptors cause a reduction in conscious level and an increase in euphoria, making fentanyl a drug of abuse. Fentanyl is a highly lipid soluble and has a quicker onset of action compared to morphine. Long-term usage of the drug results in sequestration of the drug in fat. This leads to even longer periods of time for the drug to be lost from the body. This high lipophilicity also makes it easier for the drug to penetrate the central nervous system. These two reasons are why fentanyl is so potent. It has a very high binding affinity to the receptors, and its lipophilicity allows it to easily penetrate the central nervous system.